Good morning, friends, and welcome to Virtual Calculus. So this is my first video lecture for calculus class, and you may notice that I have a microphone on. The reason I have that is because then, like when I turn around and I show my bald head, then you should be able to hear me at the same volume, because there's going to be times when I'm writing on the board and at the same time explaining something. So we're going to go ahead and get started, and our first section is going to be a review section, and partially that's because we need to kind of reacclimate to the math environment. Partially that's because trigonometry is such an important aspect of working in calculus, and it's a really strong prerequisite skill that we need to have. So, specifically with trigonometry, we need to be able to use and decipher the unit circle. And in order to use the unit circle, we have to know our special triangles. And our special triangles are going to be our ones where we have 30, 60, 90 triangles. And the word unit in general in math is referring to like a 1. And so when the hypotenuse of a 30, 60, 90 triangle is 1, this short side is going to be a 1/2. And this height is going to be a square root of 3 over 2. Okay, and likewise, with the unit circle, we have another special triangle. And I'm going to draw a better one than that. That's a little better. And that triangle is going to be a 45, 45, 90 triangle. And again, unit has to do with the hypotenuse being a 1. And when that hypotenuse is 1, this is going to be square root of 2 over 2. This is also going to be square root of 2 over 2. And some other aspects of the unit circle. I'm going to go ahead and draw a unit circle right here so we can kind of visualize what that looks like. So this is called the unit circle because this coordinate right here is going to be 1, 0, which means that anywhere I draw a radius on this circle, the hypotenuse is going to be 1. And so like this coordinate right here is going to be 0, 1, because the y value is going to be 1. All right, so trigonometry on the unit circle, we're going to use theta as our variable. Why do we use theta? I'm not really sure. I think it's just because when you put x's everywhere, a lot of times that has a value of like a number. In general, when we do angles, we use theta. But on the unit circle, the sine value is equal to the y coordinate, and the cosine value is equal to the x coordinate. All right, so let's do some examples here. So the first example we're going to do is going to be sine of 120 degrees. And so to figure out sine of 120 degrees, some of you may have this memorized, I do not. I'm going to go ahead and draw the unit circle. And I'm going to plot this triangle on my unit circle. So what does that look like? Well, to go to 120 degrees, first of all, this right here is where we start. This is 0 degrees. When you go straight up, that's 90 degrees. We got our 90-degree angle there. We got 180 degrees. This would be 270 degrees. We want to go 120 degrees. The way I do that is I go all the way to 90, and I know that I need to go 30 degrees past 90, and 30 degrees is not very much. It's going to be like right there. And I'm going to put a point. And then I'm going to draw my triangle. So I'm going to draw a vertical line. I'm always going to draw it down to the x-axis, and then I'm always going to draw the radius of the circle. So this is our special right triangle we had over here. It's just backwards. And let's put our values on here. So this right here is really a coordinate. And let's write down that coordinate. So this distance right here, since this is a 30, 60, 90 triangle, would be 1/2. Okay, except that's wrong. And the reason it's wrong is because since this is a coordinate plane, this guy's on the negative side. So I got to say negative 1/2. And this is the vertical part of our right triangle. So that one's going to be square root of 3 over 2. So this coordinate is negative 1/2, comma, square root of 3 over 2. Okay, but that's not what the question asks. The question says, what is sine of 120? And sine, by definition, is opposite over hypotenuse. Okay, and how long is the hypotenuse in all these? The hypotenuse in the unit circle is always going to be a 1, because it's a unit circle, that's what it is. So it's going to be something over 1. Well, what's the opposite side? Well, here's our angle, here's our theta. Theta is always going to be taken from the x-axis, and this is the opposite side. And we talked about that sine will always be this y value. So the answer to this question then, sine of 120 is equal to square root of 3 over 2, which is positive because it's above the x-axis. All right, let's do some more examples. Get rid of all this, guys. And one nice thing about the video, I know I'm moving along. Some of you guys are going to go at different paces. So I'm going to go fast, and then if you need to pause or rewind, you're welcome to do that. All right, let's check out another one here. Let's do cosine of 300. All right, so cosine of 300, again, I don't have it memorized. Let's draw a unit circle. Let's plot this guy. So where's 300 located? Well, here's 90, here's 180, here is 270. So there's a couple different options you can do to locate this one. First of all, you could go around 300. So I go to 270, that's kind of the nearest one, and then I would go another 30 degrees. So my triangle is gonna look like this, which looks like another 30, 60, 90 triangle, which makes sense, because if I go 30 degrees past 270, then this angle here is gonna end up being my 60-degree angle, and this angle here is my 30, so that's my triangle. Okay, what's my special triangle say? Well, I think the short side is always 1/2. The long side is always square root of 3 over 2, but remember that's wrong because now we're below the x-axis. So in terms of a coordinate, this is going to be positive 1/2, negative square root of 3 over 2. Now what's the question asked? The question asks for cosine. Well, cosine, by definition, is adjacent over the hypotenuse. So we've already discussed the hypotenuse is always 1 in the unit circle. So the adjacent side then is going to be this guy, which has a length of 1/2. So this will be 1/2 over 1, which is really just going to be 1/2. Or instead of doing the definition in the unit circle, we know cosine is always equal to the x value. That's over 1/2. So you can think of this coordinate as being cosine theta, comma, sine theta. All right, let's do some more examples here. Let's do tangent of 210. Okay, we're getting crazy. We have our third trig ratio, and if you recall, tangent is going to be opposite over adjacent. All right, unit circle time. I don't know this one by heart, and I don't know really any of them. I know kind of this first quadrant by heart. I don't really know anything else. I just draw the unit circle. And I would encourage you to do the same. You don't need to memorize all of these quadrants. It is helpful to know all of these. All right, let's locate 210. So how are we going to get to 210? Well, I'm going to go 180 degrees. That's going to go to right there. How far past? Well, I need to go 30 degrees past. So there's my triangle. Boom. How long is this side here? Well, this is the long side. So that's going to be square root of 3 over 2. In your brain, you're already saying that's wrong because it's in the negative part, my friends. And then we're down. This distance here is going to be negative 1/2. Okay, so what's the goal of this question? Well, the goal was to figure out tangent 210. And another way to say tangent is to say sine theta over cosine theta. Because sine's always going to be the opposite side, which is going to be this y value. And it's always, adjacent's always going to be cosine, which is this value. So in order to figure out tangent, here's my angle right here. It's going to be opposite, which is negative 1/2, over the adjacent, which is negative root 3 over 2. All right, obviously we're not going to leave our answer like that. That's not cool because that's a complex fraction. So how do we do complex fractions? This is just a fraction divided by a fraction, which means we're going to keep change flip. So I would do 1/2 times -1/2 times -2 over root 3. When I multiply, I got some crossing off to do there. This is gonna end up being positive because I got a chippity choppity, so I got 1 over square root of 3. Some of you are saying this is not cool because I have a square root on the bottom, and you'd be right, so we're gonna need to rationalize this denominator. Square root of 3 over square root of 3 is what we'll multiply by. So this is gonna end up being square root of 3, root 3 times root 3 is gonna be a straight up 3, donezo with that guy. So tangent is or tangent of 210 is gonna be equal to a positive root 3 over 3. All right, what's next here? Well, another thing we can do is we can say, what is, if cosine of theta is equal to square root of 3 over 2, theta is equal to question mark. So another thing we can do with the unit circle is I'm giving you the value of the cosine, and our goal now is to figure out the angle. Okay, so I'm gonna go to unit circle again, friends. So I'm just gonna draw my unit circle. I'm not gonna draw a super big one. All I really need to do is get my values where this is equal, cosine is equal to square root of 3 over 2. But now remember, this is the x value. Okay, where is the x value equal to the square root of 3 over 2? Well, this is positive, so it's gonna occur on this side. I know that this has to be the long part of the 30, 60, 90 triangle, so I think it's gonna look like this. Boom, and then I think we also have the mirror image down here. My picture is not perfect. Okay, and our goal was to figure out what are these angles right here. So I think first of all, step 1, it's 30 degrees, right? So I would say it's gonna be theta is equal to 30 degrees, or it can also be down here. So 2 ways you could do it. You go all the way around. This is gonna be 270 plus 60, or I could just say, hey, it's down 30 degrees. What's down 30 degrees? Well, I could go all the way around and go back 30 degrees, so this would be 330 degrees. Okay, so the unit circle, though, the problem with it, well, it's not a problem, it is just the way it is that I can just keep going around. So when is this equal, when is cosine of theta equal to root 3 over 2? Well, these are 2 particular spots, but I could continue to go around. So here's how I'm gonna write this answer. I'm gonna write this answer as theta, because in math, you wanna give all answers. Unless you're given some domain restriction which says, hey, give me the answers between this value and this value, we want to give all answers. So in this case, theta is equal to, well, it looks like if I go all the way around, and all the way around is like 360 degrees, and then I either go forward 30 degrees, or I go backwards 30 degrees, then I'm going to get the correct answer, or I'm going to get a value where cosine of theta is equal to this. So the way I'm going to write that then is I'm going to write that as 360 degrees n. What's n? I'm going to define n as an integer later on, because if I multiply this by 1, I go around once. By 2, I go around twice, 3 times, etc. So I'm going to go around 360 degrees a certain number of times, and then the way I can get to this value is either I can go plus or minus 30 degrees, because if I add 30 degrees to that, I'm going to go up to get my value. And if I subtract 30 degrees, I'm going to go down to get my value. So there we go. And I should actually say, and then I need to say this, where n is an integer. Because if n wasn't an integer, let's say n was like 0.5, that's not going to work. Because 0.5 times this is 180, boom, I can't do it. I'm defining it as an integer. This equation is going to give me the value of cosine. Now, I'm going to tell you this is not as important as figuring out problems like this in calculus. This is going to make or break you. This will be a problem all year. This will not. Just kind of review. Usually, we have domain restrictions on these where you don't need to write these in terms of infinity. You should understand for sure how to find this value, within this, the first 360 degrees. All right, let's do another problem, friends. example, cosine of theta is equal to 1/2. All right, let's talk about how we would actually solve this equation. Certainly you can go through the unit circle, but to solve this equation, I will do inverse sine on both sides. And if I do inverse sine on this side, the reason I'm choosing to do inverse sine is because inverse sine cancels sine. I would do inverse sine on this side. So inverse sine cancels sine, I'm left with theta. So theta is equal to sine inverse of 1/2. Let's talk about sine inverse and what that means. So you have two options with trig. First of all, I have regular sine. What do we put in regular sine? Our input is an angle. It outputs the ratio, and because it's sine, it outputs the ratio of opposite over the hypotenuse. Okay, what is sine inverse? Well, it's the inverse. What's the input in this case? Well, it's the ratio. So in this case, the ratio goes in, and what's the output in this case? It is going to be the angle. And you know that you have to use this definition. Sine inverse only works when the ratio is the opposite over the hypotenuse. Okay, so we want to figure out what angles create a sine value, and in this case it's positive 1/2. Let's draw our unit circle. All right, unit circle, where is sine equal to 1/2? Well, that's the short side of my 30, 60, 90 triangle. So if I draw the 30, 60, 90 triangle, I'm going to want the 1/2, because sine is the vertical. I'm going to want that to be the vertical part, and I want it positive, so it's got to be above the x-axis. So there's my two spots that it's going to occur. Okay, so that looks like it's going to be like 30 degrees. And then we also are going around, how far is that? Well, you can go to 180 and backwards 30 degrees. So that's going to be like 150 degrees. And actually, technically, degrees work in here. So it'll be like that and like that. That would be like my 150 degrees. That's my 30-degree angle right there. Okay, the reason we drew that is because that has a sine of 1/2. And I apologize if that's getting a little small. Okay, so I'm going to say theta is equal to 30 degrees or 150 degrees. Now, I don't know, we got to write this. Remember, we want to write all the answers. Here's all the answers. We're going to write an answer that looks like that. So I'm going to have theta is equal to, let's think about how we can write this. Well, this one's not as nice, where it's going to go boom and boom isn't nice. We could probably do it up here, but I don't want to get us confused. Let's just say 360 degrees n plus 30 or 360 degrees n plus 150. Not saying there's not a different way to write that. What I am saying is I don't want us to get lost in this right now. I want us to really focus on, we have to be able to do this for sure in one time around. Finding those values, not as important right now to worry about this, so I don't want us to focus on that and get lost there. All right, peeps, we got to go to another part of the unit circle, which is on is on radians. And you'll notice these videos are not perfect; they get kind of long. So you're going to have to just deal with my mistakes and my rambling. But that would be no different than if we were face to face. I would make mistakes, I would ramble, and I guess we will just deal with it. So we have this thing called radians, and radians, the general conversion is just that pi stands for 180 degrees. Now what's important is radians is a pure mathematical thing. Because some people are like, why do we even do these radian things? Radians is purely mathematical. Degrees is made up. So when I say 180 degrees, you know there's 180 degrees in a line because it looks like this. But why are there 180 degrees in a line? Because human beings made it up to make sense of the world. The reason there's 180 degrees in a line is because the ancient Babylonians knew the earth, or actually they thought the sun went around the earth in 365 days. 365 is not a very nice number. So what they said is, excuse me, they said 360 is a nicer number So that's why there's 360 degrees in a circle, that's why there's 180 degrees in a line, that's why we use degrees. Radians is built on something different. Radians is built more on distance. It's built on distance around a circle. So in a unit circle, what's the full distance around? Well, if this is going to be equal to 1, the distance around is going to be its circumference, which is 2 pi. Well, how far is pi? Well, that would make kind of like a 180 degree angle, but it's different because it wasn't talking about, radian's not talking about this angle of rotation. It's talking about this distance around. That's different than angles. Angles are talking about a degree of openness. Radians is talking about a distance. They are convertible to each other, and you can think of them as being very similar, and I would encourage you to do that because I think degrees make total sense to us, but they're not quite the same. And the reason we have radians is because this is pure mathematics. This is made up by human beings, which is okay. All right, let's do some examples of that anyways after that. Like I said, there's a ramble there for you about that. All right, so let's figure out sine of pi over 3. Let's do our unit circle. So pi over 3, we should know in our brains. Again, I would encourage you to relate that to the angles, but it's 1/3 of pi. So pi is going to be right here. This is pi over 2. This is going to be 3 pi over 2. And then if you go around 2 pi, you're all the way around, or 0 is going to start at this x-axis here. So I'm going to go pi over 3, which is going to fall in this. All right, so if I separated pi into thirds, it looks like I'd be like right here. So this is going to be my triangle. Now this distance, the pi over 3, is out here. I went that distance around. Again, that's what radians are all about. If you want to think about it at an angle, that's fine. It's not quite correct, but it's going to work either way. All right, long story short, that's going to give me a 30, 60, 90 triangle, which means that this high, long side is root 3 over 2, and they're both positive in this case. I'm worried about sine, which is root 3 over 2. This is positive root 3 over 2. Donezo with that. Let's talk about some conversions here that we would definitely want to know. I'm just going to write an example, even though there's not many. It's not really an example. Pi over 2, we know is 90 degrees. Pi over 3 is really just 180 divided by 3 is 60 degrees. We also have pi over 6, which is 180 divided by 6. I'm probably in your way here. Is going to end up being 30 degrees. And last one, pi over 4 is equal to 45 degrees. So everything is going to really come back to these different angles. So these are all the important ones in the first quadrant. Everything else is going to be kind of built upon these. Let's do an example to show you what I mean. Let's do cosine of 5 pi over 6. And for cosine 5 pi over 6, let's draw our unit circle. And let's think about how can we get to 5 pi over 6. Well, what is this close to? Well, 5/6 of pi is getting close to pi. So here's pi. How far back would I need to go? Well, I think if this is pi, if I take a pi over 6 away, I would have 5 pi over 6. So I'm going to go back pi over 6, which is 30 degrees. So there is going to be my spot. And my height here is 1/2. This length here is square root of 3 over 2. And this is going to be negative, and this is positive. So what am I looking for cosine? Cosine is always going to be the x value of this. Remember, this is a coordinate right here, and this coordinate would be negative root 3 over 2, comma, 1/2. And this value is going to be the x value, which is going to be negative root 3 over 2. We'll leave it just like that. Let's do one more example for the unit circle. So this example, I want to do sine of 7 pi over 4. You know what, I don't wanna do that. Let's do 9 pi over 4. So sometimes I'm gonna go off script, sometimes it works really well, sometimes it's a disaster. If it's a disaster, the video is probably still gonna go, so we'll just adapt as we go. But I wanna give it, this example is a little bit different than this one. I wanna try a different quadrant. All right, let's check it out. Unit circle, where's this gonna fall? Well, pi over 4 is kinda like 45. So if we separate this, this is like pi over 4. And then if I add another pi over 4, I'm at pi over 2. So I could just count around. Or, what I can do on this one is I can go and say how many around. Well, this is two whole pi's, right? When I do 9 pi over 4. So it's gonna go all the way around, that's 2 pi. How much further do I need to go? Well, I would need to go, actually right here, that's by coincidence. I did not mean it to end up right there. So there's my spot for this, because I went 2 pi around, which is like 8 pi over 4 is 2 pi. And then I need an extra pi over 4, so I'm gonna end up right here. So what's my triangle look like? Looks like a 45, 45, 90, which means this is root 2 over 2, this is root 2 over 2 as well. And what are we asking for? Well, they're the same in this case, they're both positive, but I want the y value. The y value, or the height, is root 2 over 2. So in the end then, this is gonna be equal to root 2 over 2. Okay, so let's review our goals really quickly here. So what do I want you to be able to do? The number one thing is I want you to be able to figure out, if I say sine of 9 pi over 4 or sine of some angle, you can draw that triangle on the unit circle, and then you can give me the correct value for this. Okay, and same goes for cosine, same thing goes for tangent. In terms of figuring out angles, I would say you should be able to figure out like cosine of, let's say square root of, if I said cosine theta equals square root of 3 over 2, you should be able to figure out that in one time around where that occurs. So what I mean by that is I know this is when the long side is going to be positive for the x, so like boom and boom. We already did that example probably, I think. But being able to figure out this within one time around. All right, that's going to wrap up our unit circle review for today. And hopefully that all made sense.